Okay, my name is, well, first of all, thank you to DevOps Barcelona for having me, for inviting me to join, and thank you for attending. My name is Juan Luís. I work in Red Hat as a senior solution architect, okay? And today, we are going to talk about how to accelerate, how to improve the DevOps strategy in companies, in the organizations, especially when you have to deploy enterprise Kubernetes platform like Openshift or like any other, okay? So how many of you, how many of you knows this diagram? All of you. Good. And how many of you knows the second one? Okay. So that's the thing. So in many organizations, okay, in my experience and in my opinion that I see in many organizations, there is a very high, strong of maturity and agility in the depth part of the story. But when you go to talk to the operators, system administrators, and so on, for instance, in banks and an insurance company and telcos and so on, whoa, the ops guy, it's another story. So the ops guys normally say, okay, I have my ITIL, ITSM procedures, my ticketing tooling, and things like that. Okay, so whoa, take it easy. So you are telling me that you have the ability to deploy your application on your own, from development to production? Are you crazy? Are you kidding me? No. You have to take it easy at this part, okay? So the thing is, okay, we should not delete or remove or move apart their tools or procedures or things like that. The other strategy is, okay, we could integrate your tooling, we can integrate your procedures in order to make more agile, okay? And that's one of the key things of the success of this story, okay? When you talk about Kubernetes platforms and things like that, they blow their minds, okay? So it's important to integrate their tools and procedures, okay? And basically, one of the things that we can do here is to promote an APIfication of the operations in general, okay? So it's a good approach to provide the ability to the applications teams or developers or whatever to have the possibility to deploy their applications from development to production in a very controlled way, okay, in a more agile fashion. And to do that, it's very important to implement an API in order to implement all the operations regarding to the dev side and regarding to the ops side, okay? And one of the key things here is to talk about the automation as code. Okay, more or less the automation as code is like, this formula you can see here, it's like APIfication of the infrastructure as a code paradigm, okay? So to me, it's very important to use the infrastructure as a code paradigm in order to implement all the operations related to the devs and ops part of the story, okay? And to be able to expose those operations into an API in order to consume like any other service inside the company, okay? So one of in terms of reference architecture, okay, we can, if you remember the session of yesterday from Beatriz and Nacho, from my colleagues in Red Hat, they talk about Ansible and automation. We are going to see later a demo regarding that. But when Nacho and Bea talk to infrastructure, especially regarding to the network operations, we can talk about any backend, any infrastructure networking, storage, security, third-party release automations tools, whatever, okay? On top of that, it's important to build an API in order to expose those operations, okay? And inside the automation API approach, it's important to have an automation engine, okay? And inside this automation engine, it's important to build all the technology automation modules, okay? So, for instance, when you talk to the network guys has all the expertise and all the knowledge about how to deal with networks, okay? When you talk to the security guys, the same thing, the same story, okay? So inside the automation engine, every group of the organization, in terms of infrastructure or platform or whatever, will be able to build their module in order to automate all the operations from that group perspective. On top of that, it's able to provide to the developers team the application modules. Okay, so we have like some kind of library to talk to the infrastructure, and also it's important to provide an API or library to talk to the application in terms of what kind of operations has to be done on that operations, deploy, undeploy, install, update, things like that. And that's the paradigm, okay? So in order to show an example about this approach, we are going to deploy an application, a microservices application has been built using Spring Boot, okay? And this is the application. The application is based on three microservices. Three of them are have the business logic, and there are two microservices. One of them is based on an AMQ cluster, and the second one is based on a data grid. And the use case is about to manage all the stock products in real time. Okay, so the implementation begins with the automation API. All the operations regarding to that application are deployed onto Ansible Tower. The Ansible Tower has the API in order to expose the deployment operation to sales, demo, install to third parties. That third parties could be an operator, could be a developer, or it could be an endpoint to a release automation software. Okay. In many organizations, that kind of software is very popular because all the IT governance are deployed onto that kind of stack. As Beatriz and Nacho talked yesterday, in Ansible we can implement the API in terms of playbooks. Okay, so the playbooks are the Lego pieces that we can manage, where we can combine in order to implement the API. So the source code of these modules are rely on a GitHub repo. There is the repo of the source code of the applications, okay, and the deployment of those applications are done. I implemented on Jenkins, the CI/CD server. And as you can see later, this CI/CD server is deployed into Openshift as well, okay? And Openshift is the platform to deploy the target of deployment of these applications. And later on, we have a Slack, a notification tool, a Slack channel as a notification tool in order to notify that the deployment process has finished correctly, okay? As you can see, this approach, we can use different tools, different technologies. We can combine Ansible with other automation tools. We can combine different CI/CD servers. Today, we are using Jenkins is very popular, but maybe tomorrow Tekton will be one of the most popular CI/CDs in the Kubernetes platforms. We can talk to Openshift or any other platform. We can talk to Openshift running on-prem or into a public cloud, whatever. In terms of the implementation, we can see here in the Ansible tower, there is a workflow called sales demo install that exposes the API to deploy that application. This workflow uses different modules, different playbooks. Those playbooks are in a GitHub repo, and the pipelines also are deployed into a Jenkins, and Jenkins are integrated into Openshift. Due to that, you can see those pipelines as build configurations in Openshift. Okay. So in Openshift, you can combine different CI/CD servers. Jenkins is one of the most popular, but Tekton will be another CI/CD support in Openshift. And at the end of the day, the application will be deployed into a sales demo app dev namespace. Okay. In terms of the implementations, you can see here all the different components. Okay. In the first part of the diagram, you can see the workflow in Ansible Tower. Every component in that workflow is linked to a playbook, okay? And every playbook calls an OpenShift build configuration. So we can show now the demo. First of all, I'm going to describe all the key components of the demo. I'm going to show you the demo running at this moment. And later on, I'm going to destroy all the namespace and to recreate from the scratch. Okay, so fingers crossed. Let me log into the web admin consoles. Please disconnect from the Wi-Fi network. Let me try the other Wi-Fi connections, the demo effect. Okay, so we're going to start from bottom to top. First of all, in here you can see the OpenShift web console. In here we can see the sales demo app dev, and in here you can see the 5 microservices. The first one, it's the sales event store aiming queue. This is a cluster with 2 pods up and running with a a distribute topic in order to save the ticketing events that the first microservices send to the stock processor. We're going to see later, okay? Later on, this is the second microservices, the sales data store. It's a data grid cluster having one pod. And here you can see the functional microservices. The first one is the ticket processor service. These microservices reads the e-commerce online website in order to read the requests of the user, okay? And the second one, the stock processor services, processes the tickets that the first microservices send to the AMQ cluster in order to calculate the projection into a data grid, okay? And the final step in the use case is the stock query service, and this service provides an API to read the stock, the product stock for any retail into the chains, okay? In here we have another workerspace. In this workerspace, we have the Jenkins CI/CD server running into Openshift with one pod, okay? And also, we have another workerspace to run Ansible Tower into Openshift as well. You can run, you can deploy Ansible Tower outside of Openshift, or even in the new version, you can deploy into an Openshift as well, okay? So, from the automation as a code approach, we can hear the source code of the microservices, and also I define several Jenkins pipelines, several Openshift build configurations, Jenkins pipelines. In Openshift, you can set up different build configs configuration. One of them is a Jenkins pipeline, and here you can see the source code. As you can see here, in the Jenkins image that provided by Red Hat, you can use the Openshift DSL language in order to deal with the Openshift operations, okay? So, into the DevOps tools, we have different build configurations and for every step in the workflow. For instance, if you see the sales deployed ticket processor pipeline, this pipeline has all the business logic in order to deploy the ticket processor microservices into an Openshift, okay? So, if you can see the automation part of the story, we need also the playbooks in order to integrate the Openshift operations into an API to install the application, okay? So, in here, in this Ansible workspace, we have different job templates. Every job template has linked to a playbook, okay? And that playbook is realized on a GitHub repo. So In the Ansible console, we've defined a repo in order to connect all the playbooks from GitHub to the Ansible inventory. Okay. In addition, we have also a special template. It's a workflow. Sales demo install. And in that workflow, you can see all the installation process. Every node in that workflow has connected to a playbook, okay? And the first thing that workflow does is update the repos of the inventory and also the playbooks inventory. And later on, the first thing you have to do is to log into an Openshift, check some requirements of the installations, create the namespaces where the application has to be installed, and also you can deploy create the infrastructure. Okay, if you select this node, you can see here at the right part of the screen the list of the playbooks you have available to connect to the workflow. Okay, so in this case, this node install all the infrastructure, and which means to install the AMQ cluster and also the data grid cluster. And later on, you can install the 3 microservices, and the final step of this process is to send a notification to the Slack channel to inform that the installation has been done successfully. Okay. Okay, so we have to wait 10 or 15 seconds to delete all the namespace. This is my personal Openshift laboratory in Red Hat, so it's not the most performance in laboratory in the world. Okay, so okay, done. And now we can okay, let me check. This is the token node. Save. In this case, we are using a survey in order to ask some parameters to the workflow. In this case, is the version of the deployment, v1. And let's go. Here you can see the different pipelines in the Jenkins console, and for instance, in here you can see the progress of the execution of the workflow, and And now we are checking the requirements of the installation. Later on, we are going to how the playbooks and the Openshift API is connected, showing the source code of the playbook. Okay. Basically, in order to show, for instance, this is a playbook. This is a playbook, okay, in order to start the build configurations related to the ticket processor service. And basically, the command is to call and start build, the name of the build configuration. This is the sales deploy stock processors, for instance, that the second microservices, passing some parameters to allocate that service into an namespace. Okay, let's see the workflow, how's it going on. Perfect. Well, very slow this morning, the lab, okay? But we can show the details of the implementation, okay? For instance, this is the inventory that Ansible Tower is using at this moment. In order to deploy my application into Openshift, my repo is very simple because all the OC commands are done by the Bastion node. The Bastion node is a special node into an Openshift cluster in order to perform all the administration activities. We can talk to the Bastion, or we can talk to the master nodes of the cluster. In this case, we are using the Bastion node in order to launch all the commands. Okay, so you can see the prereqs pipeline execution. If you go to the Openshift console, due to Jenkins is deployed into Openshift, you can see the pipelines into the Jenkins web console and also into Openshift web console. Okay, so the next flow, the next step in the flow is to perform some initialization activities, and the first one is to create the namespace that all the microservices should be deployed on. As you can see here, one of the amplifications that we were talking a few minutes ago, Ansible Tower has an API, has the ability to expose any playbook or any workflow to a third parties through a REST API. So you can call using a one command tool, or you can call the workflow or any playbook using the REST API. Okay. So, and that's very powerful because, as I said at the beginning of the presentation, normally this automation hub is used by another tools. In many companies, normally these kind of workflows are used by some kind of release automation management and things like that. Okay. So that's the reason what's important, the ability to expose your operation as an API. Okay, here, the project creation. the next step in the workflow is to deploy the infra needed by the applications, and which means you deploy an AMQ cluster and a data grid cluster. So if we go to the, hopefully, the new namespace, in here, Openshift is creating the AMQ cluster, okay? So in this case, the deployment of the AMQ deployment has fixed to 2 pods, okay? So in this case, you don't have the ability to scale up or scale down the cluster because the number of pods has been fixed. In here, we have the cluster, and the next step is to deploy the data grid cluster. In this case, I define having 1 pod. In this case, the data grid deployment is performing 2 steps. The first one is to install the data grid cluster, and the second step is to set up the stock cache that will have all the entries regarding to the stock of the stocks of the products. Okay. So due to, we have to inject additional configuration to the cluster, Openshift has to deploy the new version in a rolling upgrade fashion in order to move from one version to another with without losing service in that case, performing a rolling upgrade. Okay. We have at this moment, we have the AMQ cluster and also the data grid cluster. And the next step of the flow is to deploy the 3 microservices. Okay, we can see here. And if we take a look at the source code of this build configuration, this is an Openshift DSL. It's a plugin that it's included in the Red Hat Jenkins distribution. And due to that, you are able to use all the Openshift capabilities using a high-level language, very close to Groovy, and you can perform things like that. In that case, we are using also the Fabricate plugin in order to generate all the YAML configuration needed to Openshift in order to deploy the Spring Boot applications. And when you execute the Maven Fabricate deploy, the next thing you have to do is to wait that the deployment configuration has been done. Okay, and this is you can use the rollout status command regarding to deployment configuration, saying okay, the pipeline configuration has to be stuck until the deployment finished correctly. Okay. As you can see, when you have to deploy, even having a very simple Spring Break microservices, the number of dependencies on libraries and so on could be huge. So at this moment, the Maven script is downloading all the libraries and dependencies. We can check the sales, for instance, ticket processor. Okay. Another thing I would like to show is, in order to deploy all these pipelines together, I've defined a template, and I've installed that template into a service broker inside the Openshift. And you can see this template here. Where is? Okay. And here you can see the service broker entry into Openshift in order to group all the pipelines in order to deploy more easily. Okay. So, but the key things in here is, okay, we can use Jenkins today, or Tekton tomorrow, or Openshift in that case, or any other platform. But the key thing here is to keep your operational model as an API, and to try to encapsulate the implementation details besides the API, okay, in order to moving forward. For instance, during this year, Kubernetes operators and cluster federations and multi-cloud, things like that, will become very popular during this year, okay? And talking about Openshift, in Openshift you will be able to federate different clusters, okay? And probably in order to move one workload from one Openshift Playbook to another would be easy using cluster federation. But the key aspect here is to keep your operational APIs up and running. Probably due to new features into the platform, you will be able to improve the implementations to move one workload from one Openshift to another, okay? But the key aspect in terms of IT governance is to keep those APIs up and running, okay? So it will be great to have cluster federations and things like that, okay? And the implementation of the moving workloads will be improved, okay? But the API should be the same. Okay, the process is still ongoing, and in order to finish the presentation, some key aspects to remind. 4 aspects. Okay, the first one is, in many organizations, the first step to solve the problem is to review and define the operational model. Okay, there are many groups, there are many people doing a lot of things. Okay, but it's very popular to see that those people are not, don't have the activities under control. They don't have how many operations they have to do, how many activities and things like that. So the first step is to review and define your cloud operational model, okay? The second one is to define an API accordingly. Okay, so I have reviewed my operational model. I've defined all the activities and so on. Okay, we have to define an API in order to define the contracts of all the operations, okay? And basically that activity is to define the contracts around the people, processes, and tools, okay? The third one is implement those APIs, encapsulating the technical details through the infrastructure as a code paradigm. And the last one, and the most important one, is to automate everything, and try to encapsulate and to move forward into the dev space, in the operative space, taking into account that you can deploy, you can have an enterprise Kubernetes platform or any cloud provider infrastructure or whatever. But it's important to define the model, the APIs, implement those APIs using the infrastructure as a code, and automate everything in order to have the ability to moving forward. Okay. Okay, the deployment has been finished. Let's see the workflow. Okay, the stock processor is, deployment is still ongoing. Here we go. Stock processor, finish. Okay, let's check the workflow. Okay, the deployment has finished. And hopefully in here we'll see the final step saying, okay, the installation of your application has been finished and successfully. And the last thing we have to do, in this case manually, is to check that the application is up and running. So in here, okay, no stock related to the site 1. In this case, we are going to return 1 unit of the product 1 and 2 units of the product 2. And hopefully we will see, oh. Oh. Stock query service. Oh. Yeah. Thank you very much. Oof.
Any questions?
Questions or comments, or it makes sense for you? Do you feel that that kind of approach could help to you in your organization in order to win agility? Yes? No questions? So thank you very much, guys.
See you later,
Bye-bye.
guys. Off to lunch. See you later.